Today we're going to talk about area of polygons. Area is the number of square units that we find inside of a polygon. And a polygon, remember, is a closed plane figure that has at least 3 sides. We're going to specifically talk about a rhombus and a kite for a little while. A rhombus has 4 congruent sides and that has 2 diameters. A kite has 4 sides as well, 2 sets of congruent sides. It also has 2 diameters. Now the diameters are what we use to find the area. We call diameter sub 1 and diameter sub 2. To find the area of either one of these, we take half of the diameter sub 1 times diameter sub 2. Now let's look at this kite. We have all the information that we need. We notice that diameter sub 1 is going to be 3 meters plus 3 meters. Diameter sub 2 is going to be 4 meters plus 5 meters. So we are going to take half of 6 meters times 9 meters. It doesn't matter the order because commutative property says it doesn't matter. And we end up getting 27 square meters. Okay, so sometimes when I'm given a figure, I have some missing information. So what do I know here? Well, I do know that BD is 8 plus 8, which is 16 centimeters. I do know that EC is 15 centimeters. What I don't know is AE. So what am I going to do here? Well, I'm going to use the Pythagorean theorem to figure out the missing measure of AE. A squared plus 8 squared equals 10 squared, and when I do all of the work for that, I get that A equals 6. So I now know that AE is 6, EC is 15, and AC then is 21 centimeters. When I take 1/2 of 21 times 16, I'm going to get 168 square centimeters. What if I want to find the area of a regular polygon like an octagon or a pentagon? So let's inscribe these and see what we can do with them. The first thing I have here I'm going to try is an inscribed regular octagon. Now, if you look at this octagon, I can see here I have the center of P. And the distance from the center to any side of a regular polygon are the radius. I have PM as a radius, PN is also a radius. The diagram also shows that the center and the radius of this circumscribed circle. Alright, so now we have a new vocabulary word called an apothem. And the apothem is from the distance from the center to the side of a regular polygon. Not to the circle, but the side of a regular polygon. Okay, the apothem is the height to the base of an isosceles triangle. The radii are the legs. The word apothem refers to a segment as well as length for a given regular polygon. Think of an apothem as a segment and an apothem also as length. Now, we can find out the measure of the central angle because we're going to divide by 8, okay? We're going to, in this case, because that's the number of sides that there are. Remember, central angle of one regular polygon is formed by the 2 radii, okay, drawn to consecutive vertices of the polygon. Let's look at this problem. It says to find the measure of angle AFB, angle AFG, and angle GAF. Well, what do I know? First of all, I know that this is a pentagon, 5 sides inscribed in a circle. I know that the measure of any central angle of a regular pentagon is 72 degrees. I know that angle AGF and angle FGE both measure 90 degrees. I know that segment FG is perpendicular to segment AE. Now, As I look at this, I kind of need to break it down. And I know that angle AFB is a central angle. Well, since central angles measure 72 degrees, then angle AFB also measures 72 degrees. I know that angle AFG is half of the central angle because it's the FG is the perpendicular bisector, therefore that is 36 degrees. I also know that angle GAF is left, and 72 plus 36, and take that away from 180, and I get 54 degrees. Okay, so notice we've been finding the area of triangles. And so you can find the area of any regular n-gon by dividing it into congruent triangles. For area, we use the capital A, equals area of one congruent triangle times the number of triangles. Now, we can also say that we can find the area, A, again, an uppercase A, is equal to 1/2. You have here a lowercase a and an uppercase p. That lowercase a is the apothem. The uppercase p stands for the perimeter. So we can say half of the apothem times the perimeter. Or we can say half of the apothem times the n sides, and s is the side length. All right, so now I have here a 9-sided figure with a radius of 4, and I also can find out the central angle, which is 40 degrees. Now, when I drop the apothem, I'm going to find out that each angle then is 20 degrees. I'm going to have to use sine and cosine in order to find out the missing measures. And if I do that, I have 1m, because that's the apothem, but I have 2 n's because that is the base. So I have here 1/2 of m times 2n times the number of sides. And when I do all of that work and put it in on my calculator, I get 46.3 square centimeters. Pause the video and look at the work done here, and then restart it when you are ready to move on. Next, we're going to find the area of a pentagon. What are we missing? Well, we're missing a measure of one of the sides, but I can tell you, I can use the Pythagorean theorem.